Dear students, hope you are all doing well. Today I am going to discuss the first assignment of Electronic Waste Management. The first question is, which of the following e-waste estimation method is more frequently adopted? So, he has given factor models, time series analysis, output input analysis, disposal related analysis. So, based on available methods, e-waste estimation methods were classified into 4 categories. The first is disposal related analysis. Disposal related analysis, this method uses e-waste figures obtained from collection channels, treatment facilities, and disposal sites. So, disposal related analysis uses all this data. Second method is time series analysis. So, in time series analysis, forecast the trend of e-waste generation by exploring historical data into future. Okay, and coming to third method, input output analysis. So, in input output analysis, one of the most frequently used method in multiple modal variations. Multiple modal variations. So, applied for estimation of e-waste generation in many regional and country studies. It can be used in regional areas and throughout country areas. So, answer C for question number 1. Coming to question number 2, proper management of e-waste can provide us. So, obviously, management of e-waste. Management of e-waste. So, when we are able to manage all the waste that is produced from electronic, so we will get social benefit, we will get economic benefit, we will get environmental benefit. So, that is all the above. Answer D for question number 2. Coming to 3, among e-waste generated due to small household appliances, the major waste component of. So, obviously, generally in every situation we use plastics in small households, generally in living areas. For every work we carry plastic. So, plastic is the main waste that is generated in small households. So, answer D for question number 3. Coming to question number 4, out of the following e-waste estimation methods, which is the least explored method due to complexity and high uncertainty in long-term patterns. So the same methods were discussed in question number 1, and most frequently used method will be input and output analysis, that was already discussed. Now coming to given options, factor models. This is the method which will be used, least explored method. Least explored method will be factored method, and input and output analysis. So this method will be more frequently used. You need to remember both these questions. So A for question number 4. Coming to question number 5, which of the following state in India is lowest contributor to e-waste quantity in country? So generally all the states will produce some e-waste. So the topmost country which produces e-waste is Maharashtra. So that will produce around 20%. Tamil Nadu will produce 13%. Andhra Pradesh will produce 12%. Uttar Pradesh will produce 10%. Both Uttar Pradesh and West Bengal will produce equal amount of e-waste. Then Delhi will produce 9%. Karnataka, this produce 9%. Gujarat will produce 8%. Among all the given options, least produced will be Punjab. So Punjab is least produces e-waste. So answer C for question number 5. Coming to question number 6. The cadmium from one mobile phone battery is enough to pollute how much volume of water approximately? So the cadmium from one mobile phone battery is enough to pollute 600 meter cube of water. That is, one mobile can pollute 600 meter cube of water. Answer C for question number 6. Coming to question number 7. Which of the following pollutant causes berylocosis? Berylocosis, very important. Obviously berylocosis will be caused by beryllium. B-E-R-Y, beryllium. Okay, because of this beryllium, berylocosis will be caused. So generally this will be occurred in switchboards and printed circuit boards. Printed circuit boards. Okay, so answer A for question number 7. Coming to question number 8. Which of the following pollutant is or radioactive? So silver, zinc, americium, chlorofluorocarbon. So out of the given 4, which of them are radioactive? So americium is radioactive pollutant. Remaining 3, silver, zinc, chlorofluorocarbons, are not come under radioactive. Answer C for question number 8. Coming to question number 9. Which of the following conclusions can be drawn from economic assessment of e-waste? So we need to assess how much e-waste is generated. So, large portion of precious and spherical special metals are lost due to inefficient recycling process. Generally, if we are not able to recycle the e-waste generated in our country, precious and special metals will be lost out. So, they will be lost. Then recovery of these materials present significant economic opportunity. So, when we are able to recover these minerals or materials, then we can use the same materials in some other locations. So, that is, if we are able to recover these materials, we can able to produce some more e-waste, some more electronic goods, and this reduces environmental impact due to mining of virgin materials. So, if we are able to recover all the materials from used electronic goods, then the same used electronic goods materials will be useful in some other electronic goods. So, these are all the benefits, these are all the assessment that we have to do. Answer D for question number 9. Coming to question number 10, which of the following is the lowest per capita e-waste generating state in India? E-waste generating state in India is Bihar. So, lowest is Bihar and highest is Delhi. So, that Bihar is the lowest state. It can generate lowest per capita e-waste. So, that is, in Bihar, e-waste will be per head is very low. In Delhi, e-waste generated will be very high per head. Lowest will be Bihar. 10th answer A. 11th, globally only 15 to 20% of e-waste is recycled, while the rest is dumped into developing countries. So, generally 15 to 20% of e-waste is recycled. And remaining around 80%. So, this 80% of e-waste, all the developed countries are throwing into developing countries like China, India, Nigeria. Okay, so this is a true statement. Answer A for question 11. 12th question. The informal sector accounts for 5% of e-waste recycling. 95% e-waste reaches to an authorized recycler. That is, informal sector accounts for 95% e-waste recycling. Only 5% waste, 5% e-waste reaches authorized recycler. Okay, so here he has given numbers reverse. For that reason, this is a false statement. Question number 13. Electronic waste varies considerably with its age, origin and manufacturer. Obviously, this is a true statement. So, the electronic waste that is generated will be more at the smaller ages and very high at the medium ages, and after age is getting increased, the e-waste will be less. That is, when we are below 20 years, e-waste is low. 20 to 35, 40 years, e-waste we generate more because we buy many electronic goods. After 40, again we will not buy any electronic goods. and depending upon the origin of country, China will produce more e-waste compared to other countries. And if the manufacturers are more in particular location, they will produce more e-waste. So this is a true statement. Coming to 14th question. If the CRT is crushed and burned, it does not emit toxic fumes into the air. CRT. So meaning of CRT is cathode ray tubes. Whenever it is crushed and burned. So whenever it is crushed and burned, it will emit toxic fumes into the air. Okay, so this is a false statement. Coming to last question. E-waste should be considered as resources and requires uses in an efficient and sustainable. So answer A, this is a true statement. So that is, e-waste should be considered as one of the resource, that is all the waste that is generated in our state or our home or our country, it will be reused in some other locations. That is, it is one of the resource and it requires use of efficient and sustainable way. That is, we can use the waste that is produced from one mobile into another mobile, so that can be worked. Okay, so something like exchange of battery, we can use it in a sustainable way. So this is a correct statement. 15th question, answer A. Thank you.